So we're going to factor a squared minus 14a plus 48. So the first thing we're going to look at is the first term. Is 1 a perfect square? It is. Is 48 a perfect square? No. Since they're not both perfect squares, it's not one of our special cases. We're going to then look at the leading coefficient is 1. So when our leading coefficient is 1, we know that we're going to have the two binomials, a and an a. And now we need the factors of 48 that add to 14. Factors of 48 that add to 14. 6 and 8. 6 times 8 is 48. 6 plus 8 is 14. We have a negative 14 here, so this has to be a negative 6 and a negative 8. Number 2, 9x squared plus 12x plus 4. So the first thing I look at to see is the first term a perfect square. 9 is a perfect square. Is the last term a perfect square? 4 is a perfect square. So now this is one of my special cases. So the first thing I do is I write my two parentheses, and I take the square root of 9x squared, which is 3x. And I take the square root of the last term, which is 2. And do I have a middle term? Yes, I do. So I put the sign there and square it. So that's my answer. Number 3, 16a squared minus 121. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. So I start off with my two parentheses, and I take the square root of 16a squared, which is 4a. And I take the square root of 121, which is 11. And then I look for my middle term. There is no middle term. It has zeroed out when I FOILed. So in order for that to happen, I need one factor that's positive and one factor that has a minus. Because when I FOIL, that middle term will disappear when I have one factor with a positive and one factor with a negative.